All right, so the first type of quadrilateral that we want to look at that's not a parallelogram is a kite. And a kite is a convex quadrilateral so we're not talking about the kind you fly, although that's what a lot of them look like. A convex quadrilateral with two pair of consecutive congruent sides. A kite is a convex quadrilateral with two pair of consecutive congruent sides. Notice here side EF and side FG are congruent, and they are consecutive or adjacent. You could say adjacent. And then sides EH is congruent to side HG. It's not a parallelogram, so we can't use the definition of a rhombus, two consecutive sides. So with a kite, two pair of two consecutive sides are congruent. Do you know what that figure is? It's a trapezoid. All right, a trapezoid is a convex quadrilateral with exactly one pair of parallel sides. Right, those parallel sides are your bases. We have an upper base and we have a lower base. They're not going to be congruent. The bases cannot be congruent. And then we have two legs. And I have the legs, side BC and side AD are legs. And we know that side AB and DC are your bases. Okay, upper base and lower base. All right, you have lower base angles here. And then we have upper base angles here. We'll look at some theorems in a minute, but notice I've already marked this for us. Lower base angles are congruent and upper base angles are congruent. No, not always. Let me take that back. They're not always congruent. Okay, let's look at the next slide. Still a trapezoid. But notice I've marked the legs congruent, so what kind of trapezoid do you think this might be? An isosceles trapezoid has congruent legs. An isosceles trapezoid has congruent legs. And that leads us to theorem 611, which is dealing with isosceles trapezoids. 611 says that each pair of base angles of an isosceles trapezoid are congruent. Okay, so here we know that angle H is congruent to angle G. And angle E is congruent to angle F. Let me just say right here, if I had diagonals drawn in this isosceles trapezoid, I could not name those angles by one letter. Now, I did not count it off on the homework that we took up last class, but I made a note on your homework. If you've got more than one angle there, we have to use 3 letters to name the angle. But since in this trapezoid I don't have any diagonals drawn, I can use just H and G instead of EHG or HGF. Taylor, did you have a question? All right. Questions on that one? Then let's look at the next theorem that says the diagonals of an isosceles trapezoid are congruent. Now, I know you already have these in your note cards, but sometimes you blindly copy and don't really think about what it is that you're writing down, so I think it helps if we talk about it again. So the diagonals of an isosceles trapezoid are congruent. So in this case, ZX is congruent to WY. Those diagonals are congruent. Okay, so just think about this. If those diagonals are congruent, do we get congruent triangles?
Yes.
How?
Because of the same length and the sides are congruent. I mean, yes, sides are congruent, so therefore they just...
So what property would allow me to say I can have congruent triangles? Side, side, side. Because if we're looking at a triangle, we know that we've got this triangle, and we have this triangle. I tried to change the color. Did it change? And they have, the legs are congruent, the diagonals are congruent, and they have a shared side, don't they? So side, side, side would be the reason that we could state that those triangles are congruent. Right, let's look at the next. This has to do with the median of a trapezoid. What does a median do to a line segment? It intersects at the midpoint. So by definition, the median of a trapezoid is the segment joining the midpoints of the legs. Okay, so the median is the segment that joins the midpoint of the legs. Here, segment MN is the median. So M is the midpoint of AD, and N is the midpoint of BC. Now, the theorem 613, or the next theorem, tells us that the median of a trapezoid is parallel to the bases. If you just want to put trap and a period, that's fine. It's parallel to the bases, and it has a length that is equal to half the sum of the bases. So in other words, in this picture, we know that MN, in this diagram, MN is parallel to both RS and QT, and the length of MN is equal to RS plus QT over 2, half the sum of the bases. All three of those segments, the bases and the median, are all parallel. Let's look at the last page.
So to find the measure of the median of the trapezoid, it's 1/2 the sum of the
1/2 the sum of the bases. So if you had, well, we'll look at some examples in a minute. Want to be sure we get through all our definitions. Here we have a triangle. So this one's the only non-quadrilateral. But the mid-segment of a triangle is the segment joining the midpoints of the two sides. Okay, so the mid-segment is a segment that joins the midpoints of the two sides. I left that out. The midpoints of the two sides. Okay, so here, segment MT is the midpoint or is the median. So M is the midpoint of XZ, and T is the midpoint of ZY. And then the final theorem, again, I think on your note card you had a lot of these all together on one note card. They were combined. But the last theorem says that the mid-segment of a triangle is parallel to the third side and its length is half the length of the third side. Okay, its length is half the length of the third side. So in our diagram, we see that MT is parallel to AC, and the length of MT is going to be equal to AC divided by 2. So if we, can I change the slide? Let's say that we have a trapezoid, an isosceles trapezoid, and we'll call this A, B, C, D.